Hi and welcome back. You are watching Engineer's Fate. Today we'll solve all those GATE questions based on Horton's equation. So the thing is simple. Just pause the video, try the question yourself. After that I will solve. So this is the question asked in GATE 2003. Please try yourself. So this is the question asked in GATE 2003, and the question states that the vertical hydraulic conductivity of the topsoil at certain stage is 0.2 cm per hour. A storm of intensity 0.5 cm per hour occurs over the soil for an indefinite period. Means he has given as intensity of rainfall, that is 0.5 cm per hour. Then he is asked us to find the infiltration rate after the storm has lasted for a very long time. Means he has asked us to what is the infiltration rate. Means he has asked us to find F actual, but in this question has he given the value of F capacity? Yes, he has given. So the vertical hydraulic conductivity, what do you mean by hydraulic conductivity? Hydraulic conductivity means that the rate at which water can pass through a permeable medium. So what is the permeable medium here? Of course he has given as soil. Means suppose this is my soil. Suppose the rainfall occurs. He has mentioned as vertical hydraulic conductivity, means the rainwater will pass through vertically, and the rate he has given as 0.2 cm per hour. Means the maximum rate which the soil can infiltrate, means the infiltration capacity, F capacity of the soil, he has given as 0.2 cm per hour. Then the storm of intensity he has given as 0.5 cm per hour. In my previous video I have told you three conditions. So the condition, one of the conditions I have told you, when intensity of rainfall is greater than F capacity, implies that what will be the actual infiltration rate? The actual infiltration rate will be the infiltration rate equal to the capacity, infiltration capacity of the soil. So here the F capacity is given as 0.2 cm per hour. So my actual infiltration will be 0.2 cm per hour. So the correct option is option B. So please note down, and after note down, please solve the GATE 17 1 mark question. So let us solve the question asked in GATE 17. This is the 1 mark question, and the question said that the infiltration capacity of a soil follows the Horton's exponential model. Means in the question he has given the equation as C1 plus C2 into e to the power minus kt. In my previous video I have told you infiltration rate at any time t, Ft equal to Fc plus F0 minus Fc into e to the power minus kt. If I compare the two equations, I can write that Fc equal to C1 and C2 equal to F0 minus Fc. Next, During an experiment, the initial infiltration capacity was observed to be 200 mm per hour. Means in the question he has given as initial infiltration rate F naught equal to 200. Next, after a long time the infiltration capacity was reduced to 25 mm per hour. Means after a long time means I have told you after a long time the infiltration rate will be constant, and that will be FC. FC he has given as 25 mm per hour. So I can write that from this C1 equal to FC, that is 25, and C2 equal to F naught. F naught is 200 minus FC is 25, that is 175. And he has given as infiltration capacity after 1 hour was 90 mm per hour. Means infiltration capacity F at T equal to 1, that is given as 90 mm per hour. And he has asked us what is the decay constant. So if I put this value in this equation, so F equal to Ft, that means 90 equal to FC. FC is 25 plus F naught minus FC. F naught minus FC, that is C2 equal to 175 into e to the power minus k into t is given as 1 hour, that is t equal to 1. So if I solve this question, the k will be 0.99 hour inverse. So this is the answer. Please note it down. So this is the question asked in GATE 2000, and in this question he has asked us to find the cumulative infiltration at the end of 2 hours. So what is cumulative infiltration depth? I have told you the total infiltration depth will be the area below the curve. Suppose this is the Horton's infiltration curve, the total infiltration depth will be the area below the curve, and I have told you we can find that by integrating from 0 to t f of t dt. So in this question he has not given the initial hour, but he has asked us to find at the end of 2 hours. Means the initial hour I have to take 0, and the end of 2 hours means I can take it as 2. And ft is he has given in the question, the same thing we have to remember, that is ft equal to fc plus f naught minus fc into e to the power minus kt. And he has given the values of fc he has given 1.34 plus f naught he has given as 7.62 minus fc he has again 1.34 into e to the power minus k value he has given as 4.182 into t. So at the end of 2 hours I have to find, and in this type of question you need to know how to integrate properly. Just integrate this thing and find the answer. So that will be 0 to 2 1.34 plus 7.62 minus 1.34, that is 6.28 into e to the power minus 4.182 into t dt. So what will be the answer? So 1.34 will be common if I integrate this thing, 1.34. So integration of dt equal to t. and the hour is 0 to 2 plus 6.28 into integration of e to the power x is e to the power x, and the e to the power any constant, if it is multiplied, you know, in the integration it will become like this, minus 4.182, and this thing will be from 0 to 2. So just simplify this thing and you will get the answer as 4.18 centimeter. Just note down this and try the next question asked in GATE 2006. So this is the question asked in GATE 2006, and in this question he has given 3 1 hour storm of different intensities values, and he has given the Horton equation, and he has asked us to find effective rainfall. So what is effective rainfall? Effective rainfall is nothing but runoff. Effective rainfall or runoff, I can write that is equal to rainfall minus total infiltration depth. Total infiltration depth. So how to find rainfall? So for first hour, let me write for first hour, the intensity of rainfall is given as 10 mm per hour. So intensity I equal to 10 mm per hour. So remember the first or second video, I have told you intensity I equal to P by T. So what is P? Equal to intensity I into T, that is 10 into, for 1 hour, T equal to 1 hour, that is 10. So runoff for 1 hour, for first hour I can write that is rainfall minus total infiltration depth, that is rainfall is given as 10. We have just found that, and the total infiltration depth means, I have told you in my previous question how to find total infiltration depth, that is 0 to T ft dt. So 0 to 1, though we are calculating for first hour, and the first hour the Horton's equation is given as 6.8 plus 8.7 into e to the power minus t. So if you just integrate it, and you will find that the integration value will be minus 2.29. So the minus 2.29, should I write that minus 2.29? No, I should be write as 0. That means there is no runoff. So let me find for the second hour. For second hour, intensity I equal to 20 mm per hour. So my precipitation P equal to I into T for 1 hour. Second hour means T equal to 1. So that will be 20. Intensity is given as 20. And if I found similarly runoff, this is for 0 to 1. So runoff, this is for 1 to 2. So that is T equal to 1 hour. So that will be 20 minus 1 to 2, 6.8 plus 8.7 into e to the power minus t dt. So just integrate it and you will find that the answer will be 11.17 mm. Similarly, for third hour, t equal to 1 and the intensity value is given as 10 mm per hour and my precipitation will be 10, and similarly runoff I can find that from 2 to 3 t equal to 1 hour, that is 10 minus 2 to 3, 6.8 plus 8.7 into e to the power minus t dt. If you solve this and you will find that that will be 2.46 mm. So effective rainfall means total I have to add all these three things. So effective rainfall equal to in the first case there is no runoff, that is 0 plus 11.17 plus 2.46. 0 plus 11.17 plus 2.46. If you solve this, you will find that the answer will be 13.6 mm. So very easy question. Next, solve the gate 18 question. So this is the question asked in gate 18, and the question said that the infiltration rate in a basin under ponding condition is given as f equal to 30 plus 10 into e to the power minus 2t and t is in hours. Next, the total infiltration depth during the last 20 minutes of a storm of 30 minutes. What is total infiltration depth? We know that the total infiltration depth will be that is integration of ft dt. So what is the range we should take? So the trick in this question that the lot of students make mistake that they take 0 to 30. No, there is a trick involved. What is the trick? Let me tell you. He has asked us the total infiltration depth during the last 20 minutes of a storm of 30 minutes. That means the storm is of 30 minutes and he has asked us the infiltration depth during the last 20 minutes of the storm. Means last 20 minutes of the storm means the range he has asked us from 10 minutes to 30 minutes. But in this equation the t is mentioned should be in hours. That means we have to make the question this range in hours, that is 10 minutes to 30 minutes. To convert it into an hour, so that will be 10 by 60 hour, that is 30 by 60 hour, and ft equal to this equation we have to write 30 plus 10 into e to the power minus 2t. So this 10 by 60 will be 0.167 and this is 0.5. 30 plus 10 into e to the power minus 2t, and if you integrate it you will get as 11.7 mm. So please note down this. The trick is the last 20 minutes of a storm of 30 minutes. In our previous question, the range he has not mentioned, so we directly take from 0 to the given asked value. So please note this question. So we have solved all those 1 mark and 2 mark question from the Horton's infiltration curve, and there is one more question left, which is actually a bonus question, and I will solve that. Just note down the question and I will solve that. Note down the question by pausing this video. So in this question, what he has done, he has given the time value, and with respect to time value, he has given the infiltration rate in centimeter per hour. The time value he has given in hours. He has given the rate constant value in equal to 4-day inverse. What he has asked us to find the total infiltration rate in 8 hours. The total infiltration rate, we know the total infiltration rate will be integration of Ft dt. So total infiltration rate he has asked from 0 to 8, means the rain has started from 0 and it has ended in 8 hours. So he has asked us the total infiltration rate for 8 hours. That means my range will be 0 to 8, and Ft dt, I know Ft dt equal to Fc plus F naught minus Fc into e to the power minus kt dt. So what is Fc and what is F naught? So I have told you the initial infiltration rate at t equal to 0. At t equal to 0, the initial infiltration rate, that is F naught. And if you just see the table, you can find that 1.1, 0.75, 0.65, 0.55. Then just notice that 0.50, 0.50, 0.50 means this is the constant infiltration rate, that is Fc. So what I can write, that is 0 to 8, Fc is 0.5 plus F naught is 2 minus Fc is again 0.5 into e to the power k is given as 4 into minus 4 into t dt. If you just integrate this, you will get as the value is 4.375 centimeter. So I hope you have understood this thing. Please note it down. So we have solved all those questions asked in GATE from Horton's equation. In our next video we will solve all those GATE questions from phi index. I hope you have figured it out how to proceed hydrology, and I hope you have understood the things and understood how to proceed, and just you need to know how to integrate the things. Then you just need to put the formula, figure out the things, and you can get the answer. So I hope you have liked this video. So please subscribe, and we'll see in our next video. Thank you for watching.